All right, doing this problem called number of 1 bits. Write a function that takes an unsigned integer and return the number of 1 bits it has, also known as the Hamming weight. Okay, this is fine. So we have to find the number of 1 bits. Now, obviously, one of the ways to do that is you go through each and every bit, right? So basically, I check this one. If it is, I go through each and every bit, and then I check whether it's 1 or not, right? And that is definitely one way of doing it. Let's quickly write the code for that. So what I'm saying is I do uh, while n is not equals to 0, let's do in count equals to 0. While n is not equals to 0, then you do if n and 1. Oops, what did I do? If n and 1 equals to 1, then you do count plus plus, and you do n equals to n right shifted by 1, right? And at the end you return count. Okay, let's run. We get an error. I think this was correct only. Bad operand types for binary operator. No, I actually want to do like a binary operator only. Then what's the problem? First type int, second type boolean. Okay, it thinks this is boolean, so um, how can I make it? Let's say int. Let's just get the bit. So a bit equals to n and 1. This is the last bit. And we can say if bit equals to 1, right? Run code. Time limit exceeded. So while n is not equals to 0, what are the different inputs? This was fine. This should be have been fine. Is this causing problem with n with right shifting? There's a total of 31 bits. I feel so that this one might be causing the issue. Let's run again. Okay, yeah. What is the problem? Why is I not, I mean, one of the things I could do is I could do like this loop. So for I equals to 0, I is less than 32, and I plus plus. And let's run this. This should work, right? Yeah, so this works. That means your n never became 0. Let's keep printing that n, that, right? Why did it never become 0? So for the first case, it did become 0. For the second case, also it did become 0. For the third case, it remained as -1 because this is a special case. Is it? So when you right shift, it 1 1 1. Basically, at some point, it becomes all 1, and then even if you right shift, it will keep coming as 1. Makes sense. So that's one thing to note, and which is completely fine. Now that's one way to look at that's one way to solve the problem, in which it will take 32 iterations essentially. But there is a faster approach. I don't remember what it's called, but it is a faster approach where you would have to loop only for those many number of times as many zeros are there. And essentially what that logic is let me quickly use a whiteboard. So essentially what that logic says is uh, for every power of 2, right? That means 1, 2, 4, 8, whatever, 16, right? Just look at them. This is 1, this is 1, 0, this is 1, 0, 0, this is 1, 0, 0, 0, and so on. For every power of 2, you can check, you do this, and n minus 1, right? So essentially that would means 1 and 0, or 1, 0 and 0, 1. This is 1, 0, 0 and 1, 1, 1, triple 0 and triple 1, essentially a 0 here and 1. And you could do a 0 and 4 ones, right? And you can see all of these are 0. N and n minus 1 is every time n and n minus 1 is 0, right? So for every power of 2, n and n minus 1 becomes 0. Now, if you look at it in general, what this does is, if you do n and n minus 1, what this does is it makes the last one as 0. That's what it does. So for, and this is what we can use. So we are counting a number of ones. So we'll keep doing n and n minus 1 till our number becomes 0, because every time you do n and n minus 1, it will remove the last one. It will convert the last one to 0. Let's take an example, right? Let's take this example of 1 0 0 1 0 0 1 1 0 0 1, right? Now when you multiply this, sorry, when you AND this with n minus 1, right? So in this case, what is n minus 1? You can imagine n minus 1 would be everything same, and this will being 0, right? So when you do n and n minus 1, this becomes 0. Now when you again, sorry about multiply, but when you AND this with n minus 1, right? What will be this minus 1? This minus 1 would be essentially everything same till here, and this being 0, right? So essentially when you do an AND, this becomes 0. Then when you do an AND with n minus 1, this becomes 0. Then when you do an AND with n minus 1, this will become 0. And then this guy minus 1 would be something like, this guy minus 1 would be, I think, 0 and all ones, right? But then when you AND them, that also becomes, finally everything will become 0, right? So the number of times you can do n and n minus 1 till n becomes 0 are the number of ones in it, and this will run only those many times as those many ones are there, so it will be slightly more optimal. There is one edge case where if n is 0, right, already to begin with, then you don't want to multiply it with n minus 1, right? That's an edge case that you want to handle. So let's come to the window here, and let's try to write the code based on that approach as well. So you do if n equals to 0, you return 0. Okay, now count equals to start with 0. Now, okay, then this is handled. This is handled here, right? While n is not equals to 0, n equals to n and n minus 1 and count plus plus, and you do return count. Okay, let's check whether this works. Again, there might be some problem because of this minus last negative value getting out of loop and that sort of a thing. N equals to n and minus 1 again, right? So for that, let's do something like uh, do maybe like a long and then do x equals to n, because I think the problem would occur. Um, yeah, the problem would occur for like minus like 31 times 30 is. Oh, my bad. I think I kept saying multiply, 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 and I actually did a multiply here. But yeah, and then minus 1. I am worried about the case where n is already minus 32, right? Then minus 32 minus 1 is exceeding the limits. Let's submit and see if that test case fails. It seems it passes, but let's give this let's give that as an input. Uh, so let's do this. Oh wait, hold on. Okay, let's see what that value is. What's the largest, smallest negative value is this. So when I give this as the input, uh, so let's add a test case. Okay, how can I add a test case? Can I modify a test case? No. How can I add a test? How can I give a custom? How can I give a custom test? Um, I think. Oh, okay. You can write your own test case maybe here. Oh yeah, you can add a test case here. Okay. Uh, okay. So you have to give it in this format. This format means what exactly? So what is? I think this is that is this guy. One and all zeros. Or how many zeros? 32 zeros. Yeah. Okay. This is 4, 4, 4, 3, 4, 5, 6, 7, 8. All right. Now let's run. Okay. Let's see this. Understand? Okay. Let me. Now I remove this. I just to confirm if n is given correctly. I'll do. And as we said, n and n minus 1 is going to remove one, but I wanna see what does it show n minus 1 as. The first time around. So this would be. All right, now let's see what happens. Already n minus 1 definitely is going to overflow. Yeah, so it basically is treating it n minus 1 as like overflow and zero and all ones. I think that's what it, yeah, that's what it is treating it as, zero and all ones. So it still works. That's why it still works. Fair enough. So you don't need to essentially handle it. But even if you wanted to handle, we would probably just add like a make the int as like a long and handle it that way. But it's good to see that even that corner case gets handled. All right, submit. Cool.